All right, thank you for joining us today. And in this video, as I promised, that right after the previous video, we are going to talk about intervals and then we solve more examples. That's what we are going to do now. So we are going to talk about intervals, and when we are done, we are going to solve like 4 examples. And then in the next video, we are going to tackle 5 examples, which I'm not going to talk about anything. We just start with everything that we learned, we combine them, and then we solve. So now let's look at intervals, right? So the first one that I want to talk about is the closed interval, right? Closed interval. So let me use something like A and B, right? And let me assume that A and B is, let me say, a point on the number line, right? And then let's say A is less than B. The idea is that I'm assuming that A is less than B so that I can arrange them. Because you see, when I'm writing something on the number line, the one that comes first should be the least value, and then the one that comes last should be the greatest value. So with close, mostly we use this less than or equal to this, like this kind of this is for the close. So I can write this one as AB. So the reason why I wrote this is like, now if A is less than B, then A comes first followed by B, right? So like if I have 1 and 2, then I need to write 1 before 2. So that's the idea. So now this is the same as S is such that A is less than or equal to S, less than or equal to B. Do you get it? So let me just pick this one from the such that the curly bracket. So you see that this is the same as A less than X less than or equal to B. Good. Because we are using the idea, this one is close, this is also close, right? Now let's look at open, right? Open interval. So with open interval, this is going to be like AB. So this is open and it goes with this. So this is going to be A less than X less than B. So that is open. Very simple. Very, very simple. So what we can do is now we can mix open and close. So I'm going to talk about mixed. So mixed interval can be like, okay, the first can be open and then last can be closed. So this is going to be A less than X less than or equal to what? B. So this is for this, and then this one is for that, right? Then we can talk about the first open and then the last closed. So this one will be A less than or equal to X less than B. Good. So this is mixed interval, right? So that is what we are going to also get from here. Then we can talk about when we don't know one length, right? So we don't know one of the length, then we are trying to see how we can also write that one as well, right? So we are talking about infinity. Maybe we know the starting point, but we don't know the ending point, or we know the ending point, but we don't know, where we started from. You get it? So that's what we want to do. So I can talk about that one. So something like um, A, B, infinity. Now, anytime you have something like this, infinity like this. So infinity, we don't know where we are getting to, so we cannot include infinity in. So infinity always we use the open, right? And this is the same as A less than or equal to, as we know, this close, less than or equal to X less than infinity, right? And this can be written as A less than or equal to X, the same thing. And this one too can be written as X greater than or equal to A, the same thing. Same thing. We can also talk about, let me say, since this one is closed, this one will be open. So this will be A less than X less than infinity. and this is the same as a less than x and x greater than a. The same thing. Same thing. Then we can talk about now this one is knowing where we are starting from, but we don't know where we are going. And then where we don't know where we are going, but we know the end point. So this is minus infinity less than x and then less than or equal to a. This is the same as x less than or equal to a. Right. So that is how it is. Then we can talk about we don't know where we are going, we know a, but open. So this is the same as minus infinity less than x less than a, which is the same as x less than a. So this is the interval forms, right? Then maybe I can add last one. Maybe we don't know where we are starting from and we don't know where we are going. Infinite, negative infinity to positive infinity. So this one will be minus infinity less than x less than positive infinity. So what you need to know is we always, use the open for the infinity. And we use the open, if it is not infinity, we use the open when we are using the strictly greater than or less than, and then we use the close when it is less than or equal to, greater than or equal to, right? And don't forget, this one too can be written as like all real values, all real numbers, like that. Yeah, and let me write like x belongs to all real numbers. So we can write something like this. So these are the open intervals. So when we are done with the questions that we are going to solve, we will try to maybe represent some on the number line, trying to represent some in the intervals form or the inequality form, right? So that's that. So this is the inequality, this is the interval form. So that's what we are going to do. So now let's take some examples and then we work through, then we will see what you can do. So solve the following inequalities and illustrate your answer on the number line, right? So what we are going to do is the example that we are going to do, we are going to solve them and we are going to illustrate our results on the number line. So let's try and have some fun. So a is equal to absolute of x minus 1 less than or equal to 2. So by this time, you know, remember what you are going to do with when the absolute is just 1, right? So, either you pick the piecewise function or you change it to plus or minus. And I'm coming to also add another 1 to it because of this guy right here. So you can decide to change this one to plus or minus x minus 1 less than or equal to 2. You pick the positive, you pick the negative, or you use the piecewise function. So any of them is going to work for you, right? So let's confirm, right? So now I'll pick the positive side, x minus 1 less than or equal to 2. So this one will be x minus 1 less than or equal to 2, x less than or equal to 2 plus 1, x is less than 3. Right. I pick the negative side, minus x plus 1 less than or equal to 2, minus x less than or equal to, then 2 minus 1, minus x less than or equal to 1. Then I'll divide through by minus 1, divide through by minus 1. So since I'm dividing 2 by minus 1, this will change to, instead of less than, become greater than or equal to 1. Sorry, minus 1. Right? We will come and draw it on normal line to know the actual interval, right? But for now, this is like when you want to use the idea of changing it to plus or minus. You can also go through the piecewise function if you want to do so. The same thing. At the end of the day, you will see that you will have the positive on one of the piecewise function, and you just need to pick the positive side and say that it's less than 2. And then when you come here, this is the negative side. You just pick and it said it should be less than 2. But the other one, the new one that I want to add is, now this here can be written as because the absolute is minus, plus, or minus 2, like the one that we are having here. So you can see that we can actually combine this and that together. So this here can be written as minus 2 less than or equal to x minus 1 less than or equal to 2. So this here can be written as this. Right. So this one can be written as this. Then since I want to make s a subject, I'll add plus 1 plus 1 plus 1. Right. So I'm going to have minus 2 plus 1 less than or equal to x minus 1 plus 1 less than or equal to 2 plus 1. So this one will be minus 1 less than or equal to x less than or equal to 3. So you see, this one, we didn't even draw the number line to check how we are going to squeeze the x into the bounds. But we were able to find out the solution straight away that this is how it is. And this is the inequality form. If you want to move it to the interval form, this is going to be minus 1. They are all of them is like close, so minus 1 and 3. So this is what we're going to get. So the number line is going to be minus 1 and 3. You can choose to go with this, but since it's close, we need to shade it. Or you can also choose to go with this, minus 1, 3. And since this is close, you can just do it like this. It's also right. Good. So that is the idea. Now let me try and figure out this here. So here we had minus 1, we have 3. But we didn't know how we are going to combine this. So let's see how we combine. We are going to learn how to combine this together, right? So we are going to pick any value here we used to test here and see if it is true. Then yeah, it worked for us, right? So that is the idea. So we can pick any value here. We can pick like negative 2. Let's plug in negative 2. So when I put negative 2 here, what am I going to get? It will be negative 2, negative 1. What is negative 3? Negative 3, absolute value of negative 3 will be 3. Is 3 less than or equal to 2? No. So here is not true. You see the way we are going to check it. Good. Then, now we go with the one in the middle here. So we can pick anything here. We can pick 0, we can pick 1, we can pick 2. Right? So let's pick 1. If I plug in 1 here, I'll get 1 minus 1, which is 0. Absolute of 0 is 0. Is 0 less than or equal to 2? Yes. I can pick like 0, 2 in the middle here. When I put 0 here, 0 minus 1 is negative 1. Absolute of negative 1 is 1. It's 1 less than 2. Yes. So any value that you are going to pick from there, it will satisfy the equation. Then I need to look at this after 3. I can pick 4. 4 minus 1 is 3. Absolute of 3 is 3. 3 less than this? No. So this is also not going to work. So you can see that now the interval should lie between negative 1 and 3, which we had it right here. Now we are having this and this because it's already this. So we are going to have minus 1 less than or equal to x less than or equal to 3. And this is the same as minus 1 and 3. So this, or if you want to use this as you've illustrated it here. Right. So we are having more fun. Let's go. Let's do another one. B. Let's assume that we have absolute of x minus 2 greater than or equal to 4. Let's have more fun. So same idea. Since 1 absolute, we can do something like 1 plus or minus x minus 2 greater than or equal to 4. Right? And then when I pick the positive side, I'll have x minus 2 greater than or equal to 4. So x minus 2 greater than or equal to 4. X is greater than or equal to 4 plus 2. X should be greater than or equal to what? 6. So this is what you are going to get from the positive side. Now let's look at the negative side. Minus x minus 2 greater than or equal to 4. So distribute the minus. make as a subject. This one will be 2, divide 2 by minus 1. Then this one will be x. Now, since we are dividing 2 by minus, the sign will change, and then we are going to have minus 2. So for us to solve this, we need to put it on the number line to test. But you see that we said this can be written as this. So the real question is, when the sign 2 is this, can we rewrite it in some like form like this? Yes, but it will be a little bit like different. So this here can be written as x minus 2 greater than or equal to 4, or x minus 2 is less than or equal to minus 4. So you see that this one, because it's greater than this, we are going into two ways, right? We since this one we have some values of x that when we pick, it will be less than 4. At the same time, when you pick the negative aspect of this, right, and if this one is negative, then definitely this one too will be greater than that, or to be less than that. The idea is like when you are dividing 2 by minus, like you see that the sign changes. So when you pick the positive side, this will be the positive side, which we have it right here. You see that? But when I pick the negative side, what happened? I'm trying to divide 2 by minus. So when I divide 2 by minus and I put the minus here, the sign changes what is here. So the same thing that we were trying to do here. Here, when I pick the positive side, you will see that the positive side will be this. And when I pick the negative side, it will be just sign will change and it will be this form. So it's the same thing that we're trying to do. So here, this one is like the positive side. Sorry, this one. And we had x to be equal to, x should be greater than or equal to 6. This one, when I move the 2 there, I'll have less than minus 4 minus plus 2. And then I'll have x is less than minus 2. So we see that you've gotten the same thing here, you've gotten the same thing here. So now let's put it on the number line and find out which interval satisfy the equation. So let's pick anything here, plug it in and check if it is true, like negative 3. When I put negative 3 here, negative 3 minus 2 is negative 5. Absolute of negative 5 is 5. Is 5 greater than or equal to 4? Yes, it is true. So this one works. Let's pick anything here. You can pick 0 so that you'll be fast. When I put 0 here, 0 minus 2 is negative 2. Absolute of 2 is 2. Is 2 greater than or equal to 4? No. So in the middle, it's not going to work. Okay, let's pick anything beyond 6. Can pick like 7. 7 minus 2 is 5. Absolute of 5 is 5. Is 5 greater than or equal to 4? Yes, of course, it's true. So you see that this one is like going, this one is shaded because close, close. So this one is going like this, and this one too is going like that. So we know the beginning, but we don't know where we are going. Here too, we know the ending, but we don't know where we were starting from. So this one is like infinity, right? So that is how it is. So it means that this here is like the x values are less than minus 2. Can you see that? Like, I mean, everything here that satisfy the functions are less than minus 2. So x values are less than minus 2. And then x here, x values are greater than 6 because any value here is greater than 6. So this one will be greater than or equal to 6. So you see that this is the same as this. This is also the same as it. It's not always the case. Always you need to what? Check first. You need to check and see if it is true. So how can you write this? If you want to write this, then this one will be like or, so this or this because of this. So this one can be written as, so always we need to pick the one which is small. So we know this. So we are going to have something like so you see that x is going to infinity. So we are starting from infinity less than x less than or equal to minus 2. This is how we can write it in the full interval form. We said this one infinity will always use this. Then this one too will be 6 less than or equal to x less than infinity, because this one too is going to positive infinity. Now writing this one in the interval form, we are going to have minus infinity minus 2 close. Remember, when we started this course, we said or is union. Good. So this one will be union, then this one will be 6 positive infinity. So this is how we can write the function. This is how we can write the function. Very nice, right? Let's do last fun thing, and then I think we can think about solving a lot of complex examples, and then we take it from there. So let's take C. Let's assume that we have s squared minus 4 is less than or equal to 3. So this kind of thing is like we don't have any absolute. So it's very simple for us to do this, right? Very, very simple, right? So, maths is like you look at the thing, then you find your own way of doing them, right? In the nice way. I think this one's supposed to be minus 3. So here I can decide to, since there is no absolute, I can decide to bring this one here. So x squared minus 4 plus 3 less than or equal to 0. X squared minus 1 is less than or equal to 0. Now this is difference of two squares. So x plus 1, x minus 1 less than or equal to 0. Right. Yes. Then what can I do? X plus 1 is less than or equal to 0. X will be less than or equal to minus 1. X minus 1 is less than or equal to 0. X is less than or equal to 1. But for us to check whether it's true, we need to put it on a normal line to check. The same idea, pick any value here, plug it in, and see if it is true. So I pick negative 2, I put it here. So negative 2 here. So what is negative 2 squared? 2. 2 minus 4 minus 2 is minus 2 less than or equal to, no, this is not true. So this is out. Let's pick a number between here. Very simple, 0. When I put 0 here, is minus 4 less than or equal to minus 3? Yes, of course. So in the middle here is going to work. Let's pick something like 2 here. 2 is minus 2 less than or equal to minus 3? No. So it means that this is also not going to work. So the interval for this is going to be minus 1 less than or equal to x less than or equal to 1. And this is the same as minus 1 and 1. Good. So this is what we are going to get at the end of the day. Right, at the end of the day. Can I solve one? Let me solve one last example, and then maybe, yeah, we can close. So let me solve one last example. Okay. Let me solve one last example so that we can start with the other one. So let's look at this example here. Here we want to find the intervals that satisfy the inequality, right? So we have 1 over 2x minus 1 greater than 1 over x minus 3. We want to find the interval that's going to satisfy this inequality here. And one thing that we need to know is, our normal math will be like, okay, let's do cross multiplication. This one multiply this one multiply this. But because of this is not equal to sign, because of this sign, we need to do something. So what we are going to do is, we don't want to cross this one and cross this one. See, when we do the cross multiplication, we are going to have x minus 3 greater than 2x minus 1. When you do that, what we've done is we've eliminated all the x minus 3 function on this side, and then 2x minus 1, 2 on this side. So the best way to do is, we need to do it in such a way that, okay, at least we have this guy 1 on this side. So what can I do? If I want to do that, then what I'm going to do is I want to make sure that when I cancel it, I have one side. So here, I'm going to multiply the equation by x minus 1 squared, right? You see, if I have like a over b is equal to b, and I want to cancel a, I'll just multiply this one by a and multiply this one by a. So a will cancel a. But here is the case that I want to make sure when I do it, I still have a. So I will square a, I'll square a. So that one a will cancel one a, and then I'll have a is equal to a squared b. That's what I want to do on here. So what I've done is I've squared this. I'll square this one too, which is also x minus 3 squared. Then I'll use to multiply the left and then the right. 2x minus 1 greater than, so x minus 1 squared, x minus 3, x minus 3 squared, then times 1 over x minus 3. So that now you see that this will cancel one of this. So at least on the right side, I'm going to have 2x minus 1, x minus 3 squared greater than, because one of this one will cancel this. So at least on the left side, I still have this one here. And then this one too will cancel one of this. So at least on the right side, I still have one of this one here. So 2x minus 1 squared, then x minus 3. Right. Good. So now what we can do is we can try to, simplify and then we do some stuff. But, I can do some nice stuff here, what is going to be very nice. So let's do some nice stuff. Right. Good. So what are some of the nice stuff that we need to do here? I'll try to move this one right here. So I'll have something like 2x minus 1, x minus 3 squared. And when I move this one, I'll have minus 2x minus 1 squared, x minus 3 greater than 0. Now look at this. If I have a squared plus b minus, let's say, ab squared, right? I can see that I have a here, I have a here. So I can factor a out. I have b, I have b, I can factor b out. And here when I factor a out, it will be left with a. When I factor b out, nothing will be left. When I factor a out here, nothing will be left but it will be this, so that I'll have it this form. So that's what we can see from this up here. I have 2x minus 1, I have 2x minus 1. I have 3x minus 1, I have 3x minus 1. So I'm going to factor 2x minus 1 out, 3x minus 1 out, open bracket. So when I factor this one out, nothing will be left there, right? But when I factor one of this one out, it will be left with x minus 3, right? Good. Then minus, when I factor one of this out, it will be left with 2x minus 1. But when I factor this one out, nothing will be left there. So I'm going to have something like this greater than 0. Right. So 2x minus 1, x minus 3, right? In the bracket here, I have x minus 3 minus 2x minus 1, no, plus 1, greater than 0. So 2x minus 1, x minus 3. In the bracket here, we are going to have minus x. Yes. X minus, so minus x minus 2 is greater, no, this one is supposed to be greater than 0. Good. So this is what you are going to get. So now what we can do is we can just solve them. So 2x minus 1 is greater than 0. 2x is greater than 1. S is equal to 1/2. Sorry. S is greater than 1/2 because when I divide 2 by 2, then x minus 3 is greater than 0. X is greater than 3. Then I have minus s minus 2 greater than 0. Minus x is greater than 2. I divide 2 by minus 1. Then the sign will change, which will be less than minus 2. So I have 3 points. I have this, I have this, I have that. I'll draw it on the normal line and try and check if it is satisfy the equation that we started with. Is that right? Good. So let me draw the normal line here. So I have, which is the least. So we have half, we have this. So the least is minus 2 followed by half and 3. So minus 2 half and then 3. So what I'm going to do is I pick any number here, then I plug it in and check if it is true, right? But don't forget, we are going to plug it in here, right? Okay. So it means that I even need to bring my number line down here so that we can see it very well. So minus 2, 1 half, and 3. So let's pick anything here. We can pick 3. So we are going to plug in 3 here to check if it is greater than 0. 3 here, 3 here, 3 to 6. This one is going to be 5 on the top, right? No, it is negative 3 rather. Negative 3. So negative 3 here will be negative 6. Right. So negative 6 and this one will be negative 7. Then when I put negative 3 here, this one will be negative 6. And when I put negative 3 here, this one will be 1, right? So minus minus will be positive. So definitely this will be greater than 0. So this is true, right? Then what I need to do again is I'm going to pick any value in between minus 2 and half. So I think it's good for us to choose 0 because 0 is there. So when this one is 0, I'll have minus 1. When this one is 0, I'll have minus 3. And when this one is 0, I'll have minus 2. So minus minus positive, positive times minus is negative. And there's no way negative is greater than 0. Because when I multiply this one, I'm going to have negative 6. And negative 6 is not greater than 0. So it means that this here is not going to work. Wow, interesting. We can pick anything here. This is 0.5, so we can pick 1. Let's go with 1. So when I plug in 1 here, I'm going to have 1. When I plug in 1 here, I'm going to have negative 2. When I plug in 1 here, I'm going to have negative 3. So this one will be 6, right? So it works. 6 is greater than 0. Then the last point that I need to check is I need to check after 3, which we can think of 4. So when I plug in 4 here, 2 times 4 is 8. 8 minus 1 is 7. When I put 4 here, here will be 1. When I put 4 here, here will be minus 6. So minus times positive will be minus, and there's no way minus is greater than 0. So this one too is not going to work. So it means that our interval is just moving from this to this and from negative 2 to what? Infinity, which is very nice. So this will be the interval because so that the interval will be minus infinity less than s less than minus 2 or 1 over 2 less than x less than 3. So that is the interval that I've done it here. So when you want to change it to the other side, this one will be minus infinity comma minus 2 union 1 over 2 comma 3 this. So this will be the final example that we are going to do in this video. See you in the next video.